Welcome to the TraiNDE UT Practice Classes. This series introduces the basis of UT inspection and teaches how to use TraiNDE UT. This video will focus on the straight beam contact probe calibration and sensitivity settings. When starting TraiNDE UT, the software opens a login window. Log in with the credentials, session and user that were given by your trainer. Otherwise, log into the guest session. Once logged in, all the available exercises are listed on the left side. In the Tutorials section, select the Steel Plate tutorial. The description of the selected exercise is displayed at the center of the window, listing the specimens and probes available. Ensure to select the Conventional Device option from the Flow Detector drop-down menu. Click on Reset to Initial to start at the beginning of the exercise, instead of starting from where the previous user stopped working on it. Start the exercise with the Play button. When the exercise starts, three windows will open. The digital mockup allows you to select the specimen and the probe. On this window, you can use the probe to scan the specimen. It also offers settings and educational tools for performing inspections. The conventional device is a simulator of a conventional flow detector. It displays the signal of the probe according to the probe's position on the specimen in the digital mockup. The workbench shows a 3D contextual view of the inspection. It also offers educational tools to help understand ultrasonic testing. This exercise includes a V1-block, a step block with flat bottom holes, and a steel plate to inspect. In the Specimen menu, select the V1 calibration block, and in the Faces menu, select the 25 mm thick front face of this block. By opening the Probe menu in the menu bar, you can select the probe for your inspection. In this exercise, only a 4 MHz dual-element straight beam probe is available. Scan the dummy straight probe on the front face of the V1 block displayed in the digital mockup. The conventional device displays the signal at the location and orientation of the dummy probe. No signal is displayed even though the probe is located on the specimen. This is because the conventional device is set up for pulse echo and the probe selected is a dual-element probe. Open the main menu of the conventional device and select Probe. Change the pulsar mode from pulse echo to dual element. The signal now appears when scanning the probe. The default configuration of this exercise activates the digital probe. With this option enabled, the probe is considered as always in contact with the specimen. This is why the signal remains displayed when the dummy probe is not in contact with the touchscreen. The digital probe option also allows the probe to be moved with the mouse or with a finger. You can activate or deactivate it in the digital mockup. When this option is disabled, the probe can only be moved by scanning the dummy probe on the touchscreen, and the signal only appears in the conventional device if the dummy probe is in contact with the touchscreen. The conventional device includes the standard features of a conventional flow detector. Its main menu allows you to navigate different categories. The category options are displayed either at the top or on the left, depending on the size of the window. You can scroll through the options when the menu is larger than the window. Some options are always displayed, such as gain, freeze, envelope, and gates information. The workbench offers a 3D visualization of the inspected part. The scene can be moved, zoomed in or out, and rotated. The 3D view can be reset to its default position. Now that you have an overview of the application's windows, let's get started with the velocity calibration. The ultrasonic wave travels within the specimen at a velocity depending mainly on the material, but also on environmental conditions. The velocity calibration ensures the measurement of proper distances. Ensure the dummy probe is placed approximately at the center of the front face of the V1 block. Set the gain to 40 decibels, either with the calculator or by clicking on the plus or minus buttons. Open the Calibration category and set the time base to 90 mm to display 2 successive backwall echoes. Enable Gate 1 and Gate 2. You can set the gates up by changing the values for start, width, and level, or by double-clicking to enable the interactive mode. Position Gate 1 on the first backwall echo and Gate 2 on the second backwall echo. You can delete the second gate's information display that will not be used for the velocity calibration by clicking on the minus button next to the gate information. Click on the remaining gate's information. Select Gate 2 and Delta Gate 1. This gives the measurement of the sound path between the first backwall echo, given by Gate 1, and the second backwall echo, given by Gate 2. You must now go to the Calibration category and set the velocity iteratively to measure the 25 mm corresponding to the thickness of the V1 block. Once velocity is calibrated, you can calibrate the zero. It eliminates the wave's travel time from the transmitting element of the probe to the surface of the inspected specimen. It then allows you to perform the measurement from the inspected surface rather than from the piezoelectric crystal. Add a second gate's information by clicking on the plus button to display the sound path measured by Gate 1. We can verify that the gate's information is correctly displaying the sound path measured by Gate 1. Change the 0 until the sound path of Gate 1 measures 25 mm. You may have to change the gate settings, specifically start and width, to keep tracking the echoes. The next step is to calibrate the sensitivity of the flow detector. For this tutorial, we are using the flat bottom holes of the step wedge as reference flows. The result of a sensitivity calibration is called a distance amplitude curve, a DAC. The DAC shows the amplitude variations of the acoustic beam transmitted by the probe within the specimen. Select the step wedge into the digital mockup. Then display the flows. Now the flat bottom holes are displayed in red in both the digital mockup and the workbench. Display the central ray of the probe's beam in the workbench. You may also use the section view to help with visualization and probe placement. In the conventional device, open the sensitivity category and click on the sizing option to select DAC. Click on Edit to start the DAC creation process. Gates 1 and 2 are hidden, and the sizing gate, in white, is displayed and will be used to set the DAC up. Place the dummy probe over the third flat bottom hole and move the gate to trigger its echo. Slightly scan the probe to find the maximum amplitude to ensure that the probe is placed right on top. You may use the envelope to help you find the maximum amplitude. Click on Add a point to record this amplitude. The gain is automatically adjusted to set this echo at 80% screen height. Repeat this process for all the flat bottom holes. If you add a point by mistake, or if you want to proceed again for the same flat bottom hole, you can either replace or remove the point by positioning the sizing gate on the range of the existing point. The point to be replaced is then displayed in red. To create a new DAC point, you need to move the gates so that it doesn't have existing points in its gate range. Once you're done, you can click on OK to finish the creation of the DAC. Save your calibration so you can load it later. In this tutorial, you saw various educational tools such as section views, flow display, and central beam ray. However, under real inspection conditions, you must rely on the information from your calibration block, probe, and signal to place the probe accurately. So, if you want to practice, you can disable the educational tools. Congratulations on completing this TraiNDE UT tutorial for straight beam calibration. You are now ready to inspect the steel plate of this exercise. We will explain it further in the next video of the TraiNDE UT practical classes. Thank you for watching this video. If you need further information, please visit our website trainde.extend.com or contact us at trainde@extend.com.